So this video is going to show you how to calculate a one-sample z-test in Excel. So we have our question over here. The claim is that only children have a higher cholesterol level than the national average. That's the claim that we want to prove. It's known that the mean cholesterol level for all Americans is 190 with a standard deviation of 15. Now notice that this is the mean cholesterol level for all Americans, and the 15 is the population standard deviation. We test 100 children and find their mean cholesterol is 195. So we want to conduct a hypothesis test using alpha equals 0.01. So let's state our null and alternative hypothesis to start with. So H0 mu equals, and the value that our null hypothesis has is 190. That is the population value. Our alternative is going to be mu, and since we want to prove that it's higher than the national average, we will have a greater than 190. Then we're going to have to calculate our test statistic. This is going to be a z-test. And again, it's a z-test because we have the population standard deviation and the sample size is very large. So the test statistic is the z-test and the t-test calculated exactly the same way. It is the difference between the sample mean, which we're given here, minus the null hypothesis mean, divided by this population standard deviation in this case, divided by the square root of the sample size, which is 100. Now, one thing to note, you have to put the denominator in an extra set of parentheses if you want the square root to appear in the denominator. If you leave it out, it will divide the difference by 15, and then it will multiply. It will divide separately by the square root, and that's not quite what we want. We want to divide the 15 by the square root first, and then divide the result. Okay, so we get a test statistic of 3.333. And so now what we want to do is we're going to convert this using the normal distribution, because this is a z-test, calculate the probability, the p-value, that we could obtain this result, or something more extreme, under the assumption of the null hypothesis. So the p-value, now the normal distribution does not have as many built-in options as the t-distribution does. So there's no norm.2t or norm.rt or anything like that. We just have norm.dist, which is always going to calculate the probability less than the given value. But we want the probability that it's more than the given value. So we're going to use our complement rule, 1 minus norm.dist. The x value is the test statistic. The mean and the standard deviation, this is a z-score, so the mean is 0 and the standard deviation is 1, and it is cumulative. And so this is our p-value. This p-value, 0.0004, is significantly less than our significance level of 0.01, and therefore we reject the null, and we conclude there is sufficient evidence to conclude that the mean cholesterol of only children is higher than the national average.